Why this story matters. Stories like this show how communities, innovation, and determination can lead to lasting improvements. Quick summary: this story highlights recent developments related to space, showing how constructive action can lead to meaningful results. NASA James Webb Space Telescope shows galaxy MO MZ14. Credit NASA, ESA, CSA, and SCI Rohan Naidu MIT. Image processing Joseph DePasquale STScI and NASA James Webb Space Telescope has topped itself once again, delivering the confirmation of a bright galaxy that existed a mere 280 million years after the Big Bang, so close to the beginning of the universe as we understand. GNN reported on the last such discovery, a galaxy 300 million years after, and scientists are now certain that James Webb will break every such record until the earliest observable light is eventually detected. The newly confirmed galaxy, MO MZ14, holds intriguing clues to the universe's historical timeline and just how different a place the early universe was than astronomers expected. Would you like to read more good news about space, NASA, science, and James Webb? With Webb, we are able to see farther than humans ever have before, and it looks nothing like what we predicted, which is both challenging and exciting, said Rohan Naidu of the MIT's Kavli Institute for Astrophysics and Space Research and lead author of a paper on galaxy MO MZ14, published in the Open Journal of Astrophysics. Due to the expansion of the universe that is driven by dark energy, discussion of physical distances and years ago becomes tricky when looking this far. Using Webb's NIR-SPECT near-infrared spectrograph instrument, astronomers confirmed that MO MZ14 has a cosmological redshift of 14.44, meaning that its light has been traveling through expanding space, being stretched and shifted to longer, redder wavelengths for about 13.5 of the universe's estimated 13.8 billion years of existence. We can estimate the distance of galaxies from images, but it's really important to follow up and confirm with more detailed spectroscopy so that we know exactly what we are seeing and when, said Pasquale of the University of Geneva, co-principal investigator of the survey. MO MZ14 is one of a growing group of surprisingly bright galaxies in the early universe, 100 times more than theoretical studies predicted before the launch of Webb, according to the research team. There is a growing chasm between theory and observation related to the early universe, which presents compelling questions to be explored going forward, said Jacob Shen, a postdoctoral researcher at MIT and a member of the research team. One place researchers and theorists can look for answers is the oldest population of stars in the Milky Way galaxy. A small percentage of these stars have shown high amounts of nitrogen, which has also shown up in some of Webb's observations of early galaxies, including MO MZ14. With galaxy MO MZ14 existing only 280 million years after the Big Bang, there was not enough time for generations of stars to produce such high amounts of nitrogen in the way that astronomers would expect. One theory, the researchers note, is that the dense environment of the early universe resulted in supermassive stars capable of producing more nitrogen than any stars observed in the local universe. The galaxy MO MZ14 also shows signs of clearing out the thick, primordial hydrogen fog of the early universe and the space around itself. One of the reasons Webb was originally built was to define the timeline for this clearing period of cosmic history, which astronomers call reionization. This is when early stars produce light of high enough energy to break through the dense hydrogen gas of the early universe and begin traveling through space, eventually making its way to Webb and us. More Webb magic. Look at all the dark matter in this new image from the James Webb Telescope. Galaxy MO MZ14 provides another clue for mapping out the timeline of reionization, work that was not possible until Webb lifted the veil on this era of the universe. As Webb continues to uncover more of these unexpectedly luminous ancient galaxies, it's clear that the first few are not a fluke. Astronomers are eagerly anticipating that NASA's upcoming Nancy Grace Roman Space Telescope, with its combination of high-resolution infrared imaging and extremely wide field of view, will boost the sample of these bright, compact, chemically enriched early galaxies into the thousands. On the early universe, 6 enormous galaxies detected from the dawn of our universe, our first glimpse back this far to figure out what is going on in the early universe. We really need more information, more detailed observations with Webb and more galaxies to see where the common features are, which Roman will be able to provide, said Eugene Alai, a graduate student at the Pennsylvania State University and a member of the research team. It's an incredibly exciting time, with Webb revealing the early universe like never before and showing us how much there still is to discover. Article GoodHeadlines.org curates positive and solution-focused stories from trusted sources around the world.